Alrighty, so this is MySQL 5.1 configuration variables part 2, and configuration files and options part 2. Here's our marketing side exam. We're a recognized leader, blah, blah, blah. Basically, we do remote database management and consulting for MySQL, Oracle applications, and SQL Server. We do it for a bunch of companies, which you can see below. So we're going to continue kind of where we left off last time, or just keep going anyway, because there are new things. Does anyone here use insert delayed? Okay, I'll go through these quickly. Basically, the delayed keyword, you can insert delayed to kind of do batch inserts, but it's one at a time. So your application sends in an insert, it sends in an insert, sends in an insert, and eventually it'll do an insert in one big batch. It's only actually useful for MyISAM tables. If you use the delayed keyword into an InnoDB table, it's just ignored. So that's important to know. It's basically a way to get around kind of table level locking for inserts in MyISAM, because although you can also do concurrent insert equals 1 or concurrent insert equals 2. So basically the max delayed threads, there we go. Max delayed threads is these are all the default values, by the way. It's 20 by default. So that's how many threads you can have for the insert delayed. If it's 0, insert delayed is disabled. So delayed insert threads, again, is a status variable. So who was not here this morning? Great, okay, super. So this morning we talked about pretty much all of these are from show global variables or show global status. Show global variables shows mostly variables that you can change. Most of the names are the same as they are in show variables, or show global variables, as they are in the my.cnf where you would set them. They all begin with a lowercase letter. So this max delayed threads, lowercase letter, so it's a system variable. The status variables are mostly counter variables, but they basically show the status of the system. They begin with a capital letter. So for example, here you have the maximum number of delayed threads as a setting you can set. You can also see how many delayed insert threads there are currently running, which is 0. So if this were like 19 or 20, you might say, well, maybe we need to increase the number of delayed insert threads if we have so many being used. There were no delayed writes, there were no delayed errors. So again, this could be, it could be problematic to have errors in an insert delayed, because in an insert delayed, the client will send a query and it'll say, okay, I've got it, no problem. But if later on there's an error, then that insert might not have actually gone through, which again, a problem. Not flushed delayed rows means how many inserts have been done but are not flushed yet to the disk. Delayed insert limit. So basically, when you're doing this kind of bulk insert using insert delayed, basically you want to process selects after this many inserts, after this many records have been inserted. So if you have like 100,000 rows to insert, because basically you have a queue, so there's a delayed queue size. So each thread can handle 1,000 inserts before it needs to then actually do the insert into the table. So the delayed insert limit is 100. So let's say you've done 1,000 different insert delays. It's like, okay, I hit number 1,000. I'm going to insert it into the table now. It's going to insert the first 100 rows and then process any selects. Because again, this is for MyISAM, which locks on insert. So you don't just want to insert all 1,000 rows, because the whole point is to avoid that locking contention. So the delayed insert limit is after how many inserts will it then process any of the selects that are waiting. The delayed insert timeout is how long the handler will wait for another insert delayed statement before ending. So basically, this is the default is 300 seconds. This is all in seconds. So if you have an insert delayed and you insert one row, insert delayed, 5 minutes later you haven't done another insert delayed, it's just going to process that one row. Let's see, delay queue size, I already talked about that. This is a per table queue size for insert delayed, by the way. So it's 1,000 rows per table. So if this fills, the insert delayed statement will hang until it's inserted that 100 rows, and then it can have another one. Max delayed threads. So max delayed threads is the maximum number of threads that can handle. Did we just do this in the last slide? We sure did. And delayed insert threads is the same thing. Oh, max insert delayed threads here. Sorry. That's the same as max delayed threads. So it's just they're the same. It's just an alias one for the other. Any questions on insert delayed? Great. Nobody's really. Only one person is using it. So
with the delayed insert threads, the max delayed threads on the first slide, just start inserting once it surpasses that limit.
Yeah.
It'll just table off.
Well, here's the thing. Like, so let's say you've maxed out all of your tables, whatever, your number of thread handlers, whatever. What will happen is just as if you were, if you didn't have delayed in place in the first place, because it has to lock and wait for it. So when I say the statement hangs, it doesn't really hang. It's the same hanging that if you would do an insert. So if you have very high volume and you're using the defaults, you might just end up, delaying the time in which you get to that hanging space. So what you really want to do is make sure that you optimize with using these variables to say, maybe you need to make your queue size bigger. You know what I mean? If you're just going to fill it up with 1,000 per second, that's not really going to help because you still have to process and insert. So like I wouldn't use insert delayed for say a log table or something. I would just depend on concurrent insert. I would set concurrent insert to 2 and be done with that. So timeouts. Backlog is the size of the TCP listen queue. So this is basically how many outstanding requests, TCP requests, MySQL can have before it just stops answering new requests. So let's say you get max connections. MySQL would like listen in the backlog for like 50 more, and then it just won't even answer. Like when you have max connections and you try to connect, MySQL answers and goes, nope, can't connect, too many connections, sorry about it. The 51st at the same time just won't even get, it just doesn't listen. Net read timeout and net write timeout are only for TCP connections, and they're just what's the timeout on waiting for a read, what's the timeout on waiting for a write. So it's 30 seconds by default, 60 seconds for the writing. Net retry count is for interrupted read connections. It's not specific in the retry count that it's only for reads. But it is for reads, which is why it's right over that bullet point. So, again, if you know you have network problems, you might increase this, but probably for most people this is plenty, and if it's not, then you probably have bigger problems. More timeouts, connect timeout. So if you, we talked about this in the last session, if you get a lot of lost connection to MySQL server, error number, whatever, if you keep losing connections, it might be because of this connect timeout thing. So you might want to increase it that way. If this variable is set too low, the aborted connect status variable will be higher. But that's not the only reason that the aborted connect status variable might be high. It might be because you have a lot of people trying to log in and wrong passwords and things like that. Wait timeout is how long to wait before killing non-interactive threads that are connected. So an interactive timeout is the same thing, but for interactive sessions. So what's an interactive session? An interactive session is when you go and you have an open MySQL prompt. So for example, here's my command line window. Clear. Oh, okay, wrong with MySQL. So I'm in MySQL. If I do MySQL-root, this is an interactive session. Right, I can type things, I get the queries back, and I can type more things. That's interactive. What's not interactive is something like this. Right, I didn't get to interact with MySQL on the command line of MySQL at all. It just ran it as a batch and came back. So same things when you're connecting with your PHP connectors or your Perl, your DVD connectors. Those are pretty much all non-interactive. So you might want 2 different timeouts because you might say, well, my code, after 5 minutes or a minute, if the code still has an open database and is just sleeping, then I don't want it, unless of course you have persistent connections, right? Then you want it even if it's sleeping. But if you have a query that runs and you just, you're done with it, you can end up getting a lot, if you don't close your database handlers properly, you can end up getting a lot of problems with max connections because you have all these open connections that have just been sleeping forever because they don't have anything to do. By default, it's 28,800 seconds. So you might want to set this low. You might want to set this to 60 seconds, right? If there's a non-interactive session after a minute, it should just go away. Interactive timeout now, I might sit and go read a document or something and come back and write a query. So the interactive timeout, you might want more. We find this a lot with people. We kind of say, do you have persistent connections? Because you've got 100 sleeping queries that are doing nothing and have been sleeping for at least 3 hours. And they're like, oh no, we had a big thing 3 hours ago, and that code in the thing just never bothered to close the database handlers properly. So, yes, question.
Wait timeout, if I'm not mistaken, has a different value. Wait timeout is a different value.
So the statement was, I think if you do a global variable versus the session variable, it's different. So we can do show global variables like wait timeout, and then show session variables. Is this what you're saying, that they should be different?
Or select at wait timeout.
Right. So one way you can see the variables, by the way, is show global, show session variables. You can also use the built-in user variables. So @ is a system variable. So @ global dot wait timeout. But this is going to be the same thing in @ session wait timeout. But this is an interactive section. So I think in any place that you do this, it wouldn't necessarily be appropriate. I'm not sure. There might be something where you're not allowed to. So one of the reasons to do it this way is that if you want to set it, you can just do that, and it's a whole lot easier. You just turn the selected keyword into a set. So I think what you might be talking about is, can I set it higher than that? Well, I'm super user here, so that might not work. Well, I guess I can. So yeah, you can set it per session. So there's no, I don't think there's anything there for that. But if you find it out, let me know. Question?
Yeah, is there a timeout for long-running queries?
Is there a timeout for long-running queries? No.
Yeah, so I got my own killer, like kill it. I would like to have picture release.
Okay, I don't develop it, but yeah, no, it was just, you would like to find that. The problem is that, you might have a reporting query that you want to go for longer. Like one thing that Pythian does is we actually have in our monitoring scripts, we have something that checks for long-running queries that are locking other threads, right? Well, what we check for is a long-running locked thread. So if something's been locked for a minute, that's a problem, right? We don't care if something's running really a long time, as long as it's not locking anything else. Once it starts locking anything else, it becomes a problem. So it's something that you can do in monitoring. It's not something that, I don't think it's anything MySQL has on the horizon, but that's a good point. So non-InnoDB disk I/O. So disk I/O is usually, it's the main source of slowness. If you're using a lot, disk I/O, reading and writing to and from the disk is a lot more expensive than reading and writing from RAM, from memory. It just, is. If you have traditional disks that spin, you have to think about okay, where are the files, and are my disk heads, do they need to seek a lot of places? Sometimes you can change your file layouts. For instance, if you have a different partition or a different disk, physical disk, or a different disk head for your logs than you have for your data. For example, the logs, you just insert, it's basically write. Whereas the data, you might read from one place, you might write to another, you might read from a third place, you might write to a fourth place. So there's a lot of disk seeking going on. So one of the ways that you can avoid some of these disk seeks is to put things on different disks, especially if if you know that you have one disk kind of going everywhere, then you might say, well, I know that this one just has to keep writing, so I'm just going to put it there. Yep?
Question is, flush will affect binlog?
Will flush affect binlog? Okay, so no, this is actually just disk changes. So when you have flush, if you set flush to on, okay, the default flush is off, and what that does is it syncs changes to disk after every SQL statement. If it's on, you write the changes to disk, and you let the OS handle the sync. So that's data, and indexes, not and not any logs. There's a parameter called sync bin log that we went over in the last one, but you can look it up, sync_bin log, that you can turn on, and you can basically sync to disk after every X number of SQL statements. So by default it's 0, which means let the operating system handle when it wants to flush to disk. Flush time by default is 0, which is disabled, and basically what it is every X seconds, so if you set it to 10, then it's every 10 seconds, close all the tables, sync the data to disk. You only really want to enable that for systems with very few resources where you really want to just like sync to disk all the time. This is not something that you can turn on. So if you see this on and you have file system problems, if you have a lot of slowness, that might be why. Operating system related variables. So skip external locking. Basically, if it's set to 1, you skip external locking. What that means is that if you need to lock tables externally, like you're using MyISAM check or MyISAM pack, you're doing some kind of file system stuff on the database and you need to lock them externally, you would set this to 0. I personally wouldn't set it to 0 just because it's not something that is basically, yeah, I mean, you would know if you need to use it because when you look at the manual page for things like MyISAM check, it says make sure that this is turned off. And there is a note that says if you use this option on a system on which lockd does not fully work, such as Linux, it is easy for MySQL to deadlock, which is why I don't necessarily recommend it. Unless, again, you really need it. Thread handling, this is really valuable for debugging Linux, so not worth it too much to spend too much time on it. 1 thread per connection is the default. There's also, the other valid value is 1 thread. Open streams is 0. This just tells you how many streams are open at the time, like replication might be using streams, things like that. There's nothing you can really do to change this number. If this number is really high, there's nothing really that you can do to make it lower. It's just a variable that's a count variable. So some Linux parameters. Who's on Linux here? Okay. Who runs it on Windows in production? Who runs it on? Very brave. It's okay. I do too on some of my clients. Who runs it on Solaris or Open Solaris? Okay, and BSD? Okay, great. So Linux parameters, since most people are using Linux. There's large file support, which is set to on, which basically uses files larger than 2 gigabytes. That's probably important if you have a database in 2010. Large pages is off, which is using memory pages greater than 4 kilobytes. If you do that, you can run the risk of having a lot of fragmentation, because if you don't fill up the memory page, right, if you just put in data into the memory page, then, but it's, you're not using the whole amount, then you end up with fragmentation. Changing this is definitely an advanced thing. I may have done it once or twice, but most people don't need that. Large page size is the size of the memory pages if large pages are used. So file descriptors. We were talking last time about inheriting file descriptor limits from root, and basically your table open cache, which used to be called table cache in MySQL 5.0 and under, is now called table open cache. If you set table cache, I think you might get a warning in the error log when you start up, but it will still start up and it'll set it properly. But you should change to using table open cache because it's table cache is deprecated because of what we saw last time, which is a table definition cache. Now there's an open cache and a definition cache. So basically, this is independent. We'll get to InnoDB open files later. This is completely independent of InnoDB open files. But basically, increasing this number, which I think this is not the default. I don't think 8,128 is the default. I forget what the default is, and it's not my note in my notes. But basically, this is a number. How many tables are in the cache? It's not, how many bytes or anything like that. It's the number of tables. And this is how many, basically if you have this, there's 1 file descriptor open for each one of these. So you want to make sure that you're not setting it too high because you don't want to run out of file descriptors. Open tables and opened tables are both status variables. They have that capital O. It's how many tables are currently open versus how many tables forever that you've opened. So again, the table open cache has up to 8,000 that it wants in there, that it can put in there, but they're not using, right now there's 224, and over the life of the server that this has been running, they have opened, 519, yes.
Is this actually tables or table data plus index in the case of MyISAM, and the .frm as well?
That's a good, so the question is the table open cache the number of tables or also the number of, I think you're right, it's the number of tables, but the file descriptors might be ×3, depending on how many you open. I think it's, I honestly don't remember if it's the .frm, the .my, the whatever it is, but it doesn't, it might just be the .frm, I'm not sure, but if it is, it doesn't actually store the definition, that's the definition cache. That's the table, table definition cache is what actually stores that. Was there another question over there? No? People just stretching. Okay. So basically, if the number of opened tables is increasing at a very high rate, which you can find the rate by like opened tables divided by uptime, then you might want to increase your table open cache. So these numbers, by the way, are from just one particular client that we did some work on. We're teaching them this variable, so it's kind of what this presentation came out of. So the numbers that you see may or may not be the defaults. They're just variables that we saw in our client were kind of explaining them. And they were better than using my test system, right? Because you want to use real numbers.
Now that the table open cache is thereby constrained.
So table open cache
Comes from some OS parameter.
right, yeah, no, that's the file descriptor limit. But if your table open cache is smaller than your file descriptor limit, then, yeah, you were here in the last session, we talked about file descriptors. So the reason that you run MySQL D safe as root, but the MySQL D process as MySQL, is you run the MySQL D process as MySQL for security's sake. You run the MySQL D safe wrapper script as root so that it can get an unlimited file descriptor. And then because it forks the MySQL process, that child process actually gets, I don't know if it's a fork or a child, sorry, I didn't mean to bastardize that, but whoever knows the right thing can put in the right words. It inherits that unlimited. But if you just started as the MySQL user, it's going to have a default limit on Linux of 1024. Even if you set your table open cache higher, because that's the file descriptor limit in MySQL, in Linux by default for non-root users. So file descriptor usage, we looked at, did we look at open? No, it's open tables. So file descriptor usage, you have open files and opened files, and then there's open files limit. So the first two are status variables. The last one is a system variable, but the system variable, it can be set. But when you do a show variables like, what that reports is the number of files that the operating system actually allows MySQL to open. If this value is 0, then MySQL can't actually set this option. So you could say, oh, I want my open files limit to be 5 million, but once you start up the server, like in the config, you can say, oh, 5 million files. Once you start up the server, it's going to get the actual maximum, taking into account what you want it to be and what the operating system maximum is as well. Opened files, so open files, this one here, this open files shouldn't really be close to the open files limit. If it is, you're going to run into a problem because you're going to run out of file descriptors. Opened files is how many files you have opened. There's no like cache or anything to decrease this, so this is just kind of a, nice to know, this is how many I've opened. Again, if you can see it increasing at a big rate, it might mean that you're flushing tables a lot when you shouldn't be because you're always closing and reopening them. So any questions on file descriptors, table, caches? Great. TCP and networking. So skip networking, if you do skip networking, if you turn that on, that means that it will not respond to, it will not listen on any TCP IP ports. So that would be for localhost socket use only, or for named pipe if you're on, or shared memory if you're on Windows. Usually you want this on. Usually you're connecting via TCP IP. Max allowed packet is the maximum allowed packets that server, that MySQL will read. If you have a master and slave whose max allowed packet is different, you'll probably get errors, especially if the slave has a lower max allowed packet, because you might get a big query into MySQL, and it's going to try to replicate, and then the slave goes, I can't replicate that, it's too big, my max allowed packet is smaller. So you're going to want them to be the same. When you have a problem with max allowed packet, you know. The error message is literally something like, just something like, it's not literally if I don't know the exact words, right? It's something like, you know, packet too large, increase max allowed packet, right? Or max allowed packet does not allow a packet this large. It's very, very clear. The net buffer length, by the way, is here because that's the per client buffer length to start with. The max allowed packet is the maximum. So whenever you have a client buffer, right, you start with the length of net buffer length. That's the minimum, and that's what you start allocating with, and the max allowed packet is the maximum. And basically, after each query, after each query, the buffer shrinks down back to the net buffer length. So you run a query, you can run it up to max allowed packet, and then it runs down. Yeah?
These indirectly limit the size of text or blob.
Do these indirectly limit the size of text or blob? Yeah, because if it's a max allowed packet, you can't.
So long blob is impossible because you can't get past this.
I don't know if that's true. I haven't run into that, but again, when you run into that problem, you know. But it's a good question. It's a good question. Easy enough to test out, right? So the other thing we went over last time is sometimes, like, there's a lot that I don't know, and you know, all I know is what I've done. But a lot of these things are just like, oh, just test it out. Set up a test server. You know, I have one on my Windows laptop, so anyone can have one anywhere, pretty much. You probably could get one on the iPhone or something, or the iPad, I guess. And just try it yourself. Try to insert a long blob when your max allowed packet is a certain amount, and see what happens. You'll probably get that error though. Locking status variables, table locks immediate. So this is how many times that a table lock was requested and gotten immediately. That's good. Table locks waited, that's bad. They had to wait. So if this is really big, it can be a problem. The uptime on this server is a lot. If this is a big rate, that can be a big problem. If you're waiting for locks, you know, 70, 80 times a minute, that can be bad. If you're waiting on a table lock once a day, maybe not so bad. COM lock tables and COM unlock tables, we talked before about how COM is just a counter that shows you how many times has somebody typed lock tables versus unlock tables. So locking system variables, we have SQL buffer result, which is off. If it's on, it forces results to be stored in temporary tables, which will release locks earlier than when it's not enabled. So if you have a lot of like long reporting queries that are blocking other queries, if you have a lot of deadlocks, setting this to on might actually help you. This is a session variable only, and it's useful if it takes like a long time to send a result to a client. You can save the results as a temporary table. You know, that MySQL internally will do that and then send the results so that it can release the locks and the tables that it had for that query. So low priority updates and SQL low priority updates. SQL low priority updates is a synonym for low priority updates. What this means is that, so by default, writes are a higher priority than reads for table level locking tables like MyISAM. Okay, and that's the default. If you turn this on, writes will be a lower priority than reads. So updates, writes. So any write that you have would be a lower priority. So right now it's more important. If an insert and the select come in at the same time, MySQL will do the insert first. Okay, and it basically, and if you have an insert and a select come at the same time, and then a second insert comes in after that first select, but before that first insert is done, MySQL will actually do that second insert again too. So if you have a lot of problems where you're trying to get in a few reads among lots of writes, you might want to make the low priority updates flag on. You can also, there are also keywords to turn, you can select low priority or select high priority. So in a specific query, you can change that behavior. You can update low priority, update high priority. So when low priority updates is off, you can actually say, you know what, I'm going to do this update, but it's a low priority. It says insert low priority into whatever, and same. So there's the high priority and low priority keywords for a select statement or an insert, an update, or a delete.
Question.
Yes.
With that, is there something similar to what we talked about with the insert delayed, where you can set a certain threshold and then it will execute, or will it just have to wait out until?
So the question is, can you set a specific threshold, or do you just have to wait it out? The answer is you have to wait it out. So basically there's a read queue, here are the things that need to get reads, and a write queue, here are the things that need to get writes. It's just going to wait until one is empty to go to the other. Okay? So yeah, so you only really need to use it when you really have an abundance, when you're really trying to get, like very few selects in this barrage of inserts, and you can never really select because you're locked for a long time. Which again is where monitoring for those locked processes comes into play. And again, it's not hard, you guys can probably write your own too, right? First of all, in 5.1, there's a process list table. So you can say, select, from process list where time is greater than, say, 60, right? So if it's more than 60 seconds and I think status is locked or something. It might not be status, it might be state, either way. So you can just run that. An information schema query, or you can do show process list and grep and awk and cut for the results. So you can put that into any nodules or something, whatever you have for your monitoring system. It's a check that we have. We have our own homegrown, handwritten monitoring system because the company started in 1997, and so there wasn't like the big infrastructure. Not everyone was using nodules in 1997, so we had ended up developing our own, and so now we're kind of stuck with it. So. I can't just say, oh, here's our check, because it won't work on, necessarily the systems. But that's basically how our check works, right? Just tests. It actually does a show process list because it wants to be backwards compatible with, we still have some clients on 4.1, which is a little crazy. So, anyway, this is another reason you might want to check for locked threads, again, because it can help you figure out, do you need to tune these or not. So the max write lock count, actually, so I did lie to you. So the max write lock count is after this many write locks, allow a read lock. However,
That's an awful lot.
That's an awful lot, exactly. So you can actually set that, but I don't think it reverses it. I don't think there's a max read lock count, though, is the thing. So if you make the low priority updates turned on, I don't think there's a max read lock count. And you really want to be careful about using this because this is not a per table setting, this is a global setting. So try not to mess with it. If you have one table, or two tables in your entire schema, that's fine, but be careful. So storage engines, these are just have, there's have CSV, have InnoDB, have InnoDB cluster. There's actually no have MyISAM because there's actually no MyISAM and there's no CSV. There is CSV. There's nothing for MyISAM because MyISAM is used by the system table, so you have to have it. CSV, by the way, is used for the general log and slow query log tables if you're logging to the slow query log and general log in a table. So MyISAM specific, here are some MyISAM specific things. So if you're not using MyISAM, take a nap for a couple slides, go jog around or something in the rain, check your email from work, whatever. So MyISAM specific, concurrent inserts. I mentioned concurrent insert before. The default for concurrent insert is 1, which means it's going to allow more than one insert at a time. It's not going to lock the tables, right? If it's 0, there's no concurrent insert, and MyISAM tables will lock for the duration of the insert. If it's set to 1, which is default, MyISAM tables will allow concurrent inserts if there is no fragmentation in the table. If you set it to 2, it will allow inserts even if there is fragmentation. So this is something that I usually just set concurrent insert to go 2. I'm fine with it. That's something that I set pretty much. My default is I will always set it to 2 because it's worth it. So delay key write, by default it's on, which means for MyISAM the key buffer, so there's the MyISAM key cache, which we'll talk about in a second, which is the cache for the indexes. There's no MyISAM data cache, there's only a MyISAM index cache. The way that MyISAM data is cached is by the file system. So this makes sense if you know what MyISAM stands for. So MyISAM is MySQL's ISAM. ISAM is the indexed sequential access method. Okay, what that means is you have the way that you access the data, the access method is sequential index. You just go, the data gets written and then it goes here and then it goes here and then it goes here, and it's written that on disk. I actually had someone ask me the other day, they were like, oh, I see there's like this InnoDB page size. What's the MyISAM page size? There is no MyISAM page size because you just grab one record at a time. That's how it works. So there's no, you know, you could say, well, there's a MyISAM page size because it's whatever the memory page size is in Linux, right? But there's no actual like disk pages like there are in InnoDB. So that having been said, the delayed key write is basically, it's on by default, and what that means is that if you have a table that you create with the delayed key write keyword in it, so it's, you know, create table through whatever delayed key write, it means that the key buffer is not flushed for tables created with delayed key write. And when I say that they're not flushed, I mean they're not flushed until you shut down the server. So that can save a lot of this guy out. It can also get you into a lot of trouble. So be careful if you want to turn that on. There are two other values. There's off, which says no tables, even if you create them with delay key write, are going to do this kind of behavior. And then there's all, which means all tables are going to act, all MyISAM tables anyway, are going to act as if they have this delay key write turned on. So the default is on, which means if you really want to not flush your index to disk, you can do that. Which, you know, again, it's, you can say, well, it's a little dangerous or whatever, but you have to actually specify in the create table, so theoretically, you know what you're doing when you do that. If you have some people who are making these kind of tables and you're not sure why they're doing delayed key write and you want to stop that, you could turn this off, for example. So keep files on create. What this means is that if you try to create a table and there's already, if there isn't a .frm file, MySQL won't register it as a table, so you'll be able to create it because it won't exist, right? The .frm file isn't there, therefore it doesn't exist. But there might be a .myi, which is a MyISAM index file, and a .myd, which is a MyISAM data file, even though there isn't a .frm file. Now, this does not happen in normal operations. You would have to, you know, have deleted something or done something, you know, on the file system to do this, to make this happen. But if you have this kind of a problem, if a .frm file isn't present, actually there's another case where that might happen, but again, it's something you explicitly said. So if a .frm file isn't present, then it will overwrite any MYI or MYD files when this is set to on. So otherwise, if it's set to off, which is the default, if set it to on, okay, so here's the thing. If you don't want to overwrite the MYI and MYD files when there is no .frm and you create a table, then you set it to on. Now, with MyISAM tables, starting in 5.0, and this I know for a fact, you can actually set, if you want the index directory or the data directory, so if you want the MYD file, the MYI file, to be in a different location than the data directory, you can actually set that as part of a create table statement. So this is where you might run into the situation where you have a .myi and a .myd but not a .frm, because maybe you copied from a different server but you didn't copy the .frm. You know, you go to create the table and you're like, oh, you've already got a, you know, do you want to give you an error that says, you know, hey, there's already a table here or not? That's when you use this. Most people don't most people don't even know about the data directory and index directory options for create table. I actually only found out when I was writing books. I only found out like a year and a half ago. It's been there since 2005. 2005 is when 5.0 was generally available. So it's not something a lot of people use. I actually prefer, even knowing that it exists, I actually prefer to use symlinks. Only because if you have a symlink, then you know, you're like, okay, there's supposed to be this .myd file here, but it's really over there. Yes, but at least it's in the place you expect it to be. So MyISAM data pointer size, which is the default pointer size in bytes to be used by create table for MyISAM tables if you don't specify max rows. Ooh, okay. Why would you ever change this? Who knows? The variable has to be between 2 and 7, and the default value is 6. A value of 4 will allow tables up to 4 gigabytes. A value of 6 allows tables up to 256 terabytes. which means that a value of 7 would allow bigger than that. 512 terabytes, is that what you said?
That would be a guess.
That'd be a guess, yeah. I mean, it's a multiple of, it's a factor of 2. So if you get table is full, you might need to increase, because it's basically how much, if you have a pointer, right, there's only a certain number, you point to number 1, point to number 2, point to number 3, it's how many pointers, how big your pointer can be. It's basically how many rows. So if you get table is full, you might need to increase this, or you might need to set max rows, you know, specifically larger when doing create table. MyISAM stats method, this is how the server will treat null values when it's collecting statistics about the distribution of indexes, right? So MySQL, when the optimizer tries to pick a plan, it picks it by using the metadata it has. So if you have, you know, certain selectivity or cardinality of your index, if you have a unique index, that means that the optimizer knows that if you're searching for a particular value, there's only going to be one row. It's going to be easy to find because you don't have a lot of different entries using that same index itself, right? There's only one entry that has that index because it's unique. So that has good selectivity. So basically, when you have a null value, it's how does the null value affect the index value distribution? So the values are nulls unequal, which I believe is the default, and what that means is that any index value that's a null is considered equal to another null value, for example, right? So two nulls that are considered equal will have the same index, which is, so basically it has a group that's the size of whatever. So if you have a table, it has a column, and it has a, you know, it's either the number 1 or null, and it's exactly half and half. Then you have one group that has, okay, I have 50 rows that have the number 1, and I have 50 rows that have the null, and it will store those data. It will store that data. Even though, as we know, like if you try to compare null to null, you shouldn't get true, you should get null. In this case, it makes a little more sense to have it be nulls. I'm sorry, nulls equal does that, not nulls unequal, right? Nulls equal makes it such that you have that group, so that makes a lot of sense. Nulls unequal means that each null value is not equal to each other, which means that if you have a table with 50 values with the number 1 and 50 values with the number null, you're going to have 51 groups. One group has 50 of the number 1s, and then you have 50 groups of 1 because each null is unequal. There's also nulls ignored, which doesn't make an index distribution for nulls. So if you have that same table, you're only going to get one group of the 50 with 1. Question?
So that'll affect indexes?
It does not affect indexes, it affects the statistics that MySQL keeps about indexes. So it actually affects the optimizer and what plans it's going to choose. Because it's how MySQL collects statistics about the indexes. It does not change any data at the indexes. It just affects how when it decides to use an index or when it decides to go with a certain execution plan. Well, does explain say it's doing a full table scan?
It doesn't.
Okay, so the statement is that he has a problem with a query. There's a date field, the index is on the date field, which is a nullable column. You actually said it's not a number, which is actually wrong. It is a number. Internally it's stored as a number. I just wanted to let you know that because there's some fields, there's some things that can only work with numeric values, and those can work with dates. So I just want to make that clear for anyone who's listening. When he runs the explain, it comes back and it says it's like using a particular index and it should be very fast, and then when he runs the query itself, it doesn't use that.
I'm wondering if this is coming into play there, because with this, it sounds like this influences what indexes will be used at execution time.
Do you find different optimizer statistics for if you're doing a search on the date is null versus the date is something, or the date is in a range, and you're finding that?
In fact, when we set the date to the affect time, I think 7, for example, it comes back immediately. That's when we have the null values.
Right.
Something like this influence.
So when you're saying is null, you get a problem. Yeah, and probably because the default is nulls unequal. So it's probably saying, oh, there's too many of those indexes and not use it. So again, I would actually try it first of all, one thing I'd do is, if you can, load that table into a test system. You may find that that fixes the problem. It might just be fragmentation or something like that.
No.
Probably not. But that would be my first. If you came to me and said, I'm going to pay you money to spend a day in my system, what are you going to do first? That's the first thing I would do, is load it and then run the query right away, because it might have different response because it's now defragmented. So I don't want to introduce too many different variables, because if I didn't test that, then it might be because of the defragmentation, I don't know. So then try to change this. But again, this is not per table. It's now going to be for every MyISAM table. Do I know why MyISAM is defaulting to nulls unequal instead of nulls equal? I'm not really sure. I would think it would make more sense to lump all the nulls together, because you're either going to search for is null, or you're not going to search for is not null. So, and nulls ignored would probably be even worse for you if you're searching for a null value, because then it would have to do a full table scan.
Yeah.
Whereas, it would have to go to X number, then it goes to X indexes to find that. MyISAM use mmap. This is actually talking about using memory mapping for reading and writing MyISAM tables. I confess that I don't know much about the whole memory mapping thing. Yes?
On the stats method, if you change that, do you have to like reconfigure the statistics somehow after you change it, or?
So when you change, the question is, when you change the MyISAM statistics method, do you have to change, how, do you have to like reanalyze the table or whatever? That's a good question. I don't know. My thinking, and I'll confirm this or not, my thinking is that it is probably a dynamic, it's probably a static variable, so you probably have to restart.
So the statistics are only kept in memory, they're not stored as part of the index table?
I honestly don't know. That, but the easiest way to probably figure that out is to do a strings on the .myi file and see what you get. It's pretty cool. MyISAM statistics index collection. The manual is very good. For people who weren't in the last session, which I said that the MyISAM manual, the MySQL manual is pretty good. It has global and session values, setting the global affects statistics collection for all MyISAM tables, setting the session. This means that you can force a table stats to be regenerated with a given method without affecting other clients. So it sounds like, yeah, you do have to. To regenerate table statistics, you can use any of the following methods.
Okay, so you do have to force it to generate the statistics in order for that to take effect.
Yes.
Okay, thank you.
And there's some caveats regarding the use of it, so if you think you want to use it, I would say read that page and, hey, we don't need zoom in. And that's even a, all right, let's go back to here. Let's go back to normal. So memory mapping, I confess I don't really know how that works or whatever. It was added in 5.1.4, so repairing MyISAM tables. So if you do end up doing like if MySQL crashes and tries to recover, if you do like a repair table, sometimes you might see a repair table, MyISAM is marked as crash, it's going to try to automatically repair it. Or you do a repair table. Basically, the recover options are basically in recovery mode. So the value can be, it's a set, so it can have any combination of the values, either default, force, backup, or quick, separated by commas. So here you have force, comma, backup. And basically, if you don't have any argument, it's the same as default. And specifying with an explicit value of blank will disable recovery, which is actually the default. So if you don't specify it or you specify blank, it actually won't do automatic recovery. If recovery is enabled, then every time MySQL opens a MyISAM table, so again, that file is open, it will check whether or not the table is marked as crashed and needs repairing. If it is the case, MySQL will run a check on the table. It will do check table, and if it comes back that it was corrupted, MySQL will attempt to do an automatic repair on that table. Now, if you have basically default is does the recovery. Actually, well, let me go, it's kind of in order. So the backup says that if the data file was changed during the recovery, then you want to save a backup of the table. see table name.myd, you save it as table name-datetime.bak. Force says run the recovery even if we lose one or more row from the data file. So, you know, it can be good because you're getting it to where it should be, but it can be bad because it can be good because you're repairing the table so you can actually use it, but it can be bad because you're losing table. So I would say if you are using force, you should always back up just in case. Quick says don't check. Basically, so MyISAM, whenever it opens, it will check to see if it needs repairing, but it doesn't just run a check table. What it does is says, were there any deletes? Were there any updates on the file on this table? If so, then I might be corrupt. So then I'll check the table. If you do quick, it will say. Sorry, that's if you say quick, it'll say don't check it unless I have a delete block, because then it might be corrupted. Normally it just checks it no matter what. And the default is a recovery without backup, without forcing, and without quick checking. So basically, it will check no matter what, even it doesn't have to only have delete blocks. It won't force the recovery. If it's going to lose more than one table, it won't force it, and it won't make a backup. So basically, it will only, by default, MySQL will only automatically repair tables if there's no data loss, which is a good thing, right? You don't want it to automatically repair if it will be, or if you do, you want a backup. So MyISAM repair threads is how many threads for doing repair, and multi-threaded repair by sorting is beta quality. So I don't think I would play with this very much. I would probably fail over to whatever my disaster recovery plan is if I found that I had to repair a whole bunch of tables and it would take a long time. I think instead of repairing a very large table, instead of trying to do it multi-threaded, I would probably fail over to whatever my backup server is. MyISAM index sorting. So when you sort a MyISAM index, it's done whenever you're loading a lot of data, you change the table and it rebuilds the index. You do a repair table, it has to rebuild the index, create an index, it has to build the index. The MyISAM sort buffer size is the buffer size for sorting indexes during this kind of building table, the repair table or create index. Okay, this is not a sort buffer on a MyISAM table query. No, it's just the buffer size for when you are adding an index or rebuilding it. So if you have a big table and you want, a repair to take less time, right? You can set this a little higher if you really want. The maximum, by the way, is 4 gigabytes before 5.1.23, 16,384 petabytes for 5.1.23 and later, assuming that you're on a 64-bit system. The 64-bit Windows limit is 4 gigabytes no matter what version, and if you put larger values in for any of these, then their maximum, they will be truncated to the maximum. MyISAM max sort file size is the maximum temporary table file size for when you're repairing a table and it has to recreate the index. So during a repair or alter table or load data from file. So if the index is bigger than this, instead of using the sort file, it's going to use the key cache instead, which actually takes longer. So again, this is just if you're doing a lot of index building or rebuilding, and it's taking a long time. If you increase max sort file size, it will be faster. Have some water. Are there any questions on anything we've gone over? We're going to start to go on to full text search. So if there are any questions on this, now's a good time to ask them. No? Great. Great. Probably because not very many of you are using this. So full text search. Anyone actually use full text search? Anyone hate full text search? Just about the same number. Anyone's going to use Sphinx and Lucene or Lucene instead of full text search? Yeah? Okay, all the hands should be up by the way. MySQL full text search is elementary, I'll say. It works for what it is, but if you're doing real text searching for a lot of textual documents, you want to use a tool like Lucene or Sphinx instead. So, full text search is MyISAM only. Here are some of the commands. You have the minimum word length is 4. So if you have 3-letter acronyms that you want to be searching on, you're going to have to change this value. And then once you change this value, you do have to rebuild the index because basically MySQL builds an index of, okay, this word appears in these documents, this word appears in those documents. So if you change the minimum word length, you have to add, you have to rebuild the index because it never went through and found those words. The maximum word length is 84. That's my question, is that characters or bytes? Was that your question?
No, I think this applies to all tables and cannot be done individually.
This applies to all tables and cannot be done individually. Just like every other these are all global variables. Any per table variable is probably going to be in a create table statement, and I'm not really going over create table at this point. There were sometimes I'll throw in something that says, oh, you can get around this by doing create table blah, but there is no such thing for full text search. And there's a built-in full text stop word file, which you can actually change, but if you want to change it, you have to recompile C code and all that kind of stuff. And yeah, I'm actually surprised. I'm sure hopefully somebody's made a plugin to make that just like pluggable, because that's probably one of the easier plugins to do. Here's a word list, go. By default, not just the FT stop word file, which has it's different for different languages, but like for index it has the, a, and common words. About, I think it's probably one of them, things like that. You can look in the manual to see what the stop word list is. Also, while it's building the index, if it finds that there's a word in more than 50% of the rows, it puts that's a stop word as well. So if you have a lot of MySQL stuff, your MySQL blog or something, every entry might have the word MySQL in it, then MySQL will become a stop word. So it does that sensibly at least. So full text search. FT Boolean syntax. This is the list of operators that is supported by Boolean full text mode. So now sometimes you can go into like a Google search, you can do a Boolean search, it's like plus Sheeri. Let's say you want to get an article that I wrote. You might be like, okay, high performance MySQL, and the first 10 pages are not me because there's 20 million other people who are doing it who are more famous than I am. So you might want to say like, okay, minus Percona plus Sheeri or something. So that's a Boolean search, right? Don't include these, do include these, because you're looking for something specific I wrote. There's basically a section on what these all mean, but basically this is default value, and if you want to change it, yeah, read the manual. I have a whole bunch of different, I have a whole list of notes here, but nobody's really using it. We're probably not going to change this anyway. Is anyone specifically using a Boolean search? Plus, minus, one person? Okay, yeah, 2 people. FT query expansion limit. So there is one neat thing that full text search has, which is the with query expansion, like key phrase. And what that means is that, let's say you're looking for MySQL in your blog posts. What with query expansion will do is it will get things that match not only MySQL, but if every document that has MySQL also has the word database in it, it will then actually start to find related things with database, the word database in it, because even if it might not have MySQL in it, it has database in it. So it kind of does this comparison to say, okay, well, all of these ones that you're looking for, most of them had this value too, so I'm going to now look and see for that value. So this is the number of top matches to use. So the default is 20. It's the number, so it might look for 20 other words that are used in the documents that use MySQL that might also make this search more relevant for you, which is kind of nice. MyISAM key cache. So we talked a little bit about it before, but basically one of the neat things about the MyISAM key cache is that there's a global one, but you can also have more than one. Basically, you can have what's called named key caches. You set them to say, so the global one is key buffer size and then key cache block size. So a buffer is a cache. Don't be fooled by the fact that MySQL likes to be inconsistent sometimes. Key buffer size and key cache block size is just the block size is 1K and the buffer size, the whole buffer size is 16 megs. You can actually have named key caches, so you can say, okay, I want the key cache named foo to have 16 megabytes, and this cache index, you can say cache index bar in foo. So you can say, okay, this specific index gets cached in this cache, and that way you can keep certain caches warmer or colder depending on what you have to do, which is really, really nice because you won't have one query that just destroys all of your key caches. Maybe you have one query that destroys one, your global key cache, but every table or every index could actually have its own key cache if you really wanted. But you can have key caches per table, per index, or if you know that you're doing a join on a few tables, you can put all those in the same key cache. So it's really, really nice. It's a little too long to explain to go into how to do that, but just look up named key caches in MySQL, and you'll find out how to do it. It's really pretty easy. So the MyISAM key cache, how does it figure out what should stay, what should go? It uses a least recently used algorithm. There's also these things called hot and warm subchains, and basically, after a certain amount of time, something will go from hot to warm, like a hot cache versus a warm cache, and then from a warm cache will be purged. So basically, I tell you that to tell you this. The key cache H threshold is 300. What this means is how fast something gets demoted from the hot chain to the warm chain, right? So after 300 seconds, it's no longer hot. If it hasn't been used in 300 seconds, it's no longer hot, it's now warm. The key cache division limit is the percentage of the key cache you use in the warm versus the hot subchain. So right now, basically, it's just saying, you can use 100% of the key cache can be in the warm. It doesn't, it doesn't have to be in hot. You can change this if you're finding that the indexes aren't doing what you're supposed to. I honestly have never changed these values. Partly probably because most people are using InnoDB, and partly probably because this is a really advanced kind of thing to be like, yeah, which subchain should you put it in, hot or warm? MyISAM key cache sizing. So here's how you can find out, okay, how much of my key cache is being used. So you have status variables, key blocks unused, and you have the key cache block size. And the key buffer size. So you multiply the number of blocks unused by the size of the blocks, and you divide by the key buffer size, and that's the percentage of used for all the key caches. Now, unfortunately, I don't think you can get statistics per cache from status. You only get it for the global, for everything. But it does add up all of the individual ones. So this is the percentage used for all key caches. So key blocks unused is how many unused blocks there are among all of your key caches, not just the global one. So this is the particular thing, the percentage used in this. They weren't using any of it, basically. The key blocks used is the maximum number that were used at any time. And again, they had 36 blocks used. So again, that was the high watermark. They're really not using a lot of their MyISAM key cache. This particular client was a lot of InnoDB. Key blocks not flushed. We talked about flushing those index blocks and when you flush them and when you don't. If this is high, you might have that, what do you call that variable before, where you flush the things. Oh, I think it's just called flush. So if you have index blocks that aren't flushed to the disk yet, they're not synced yet, they will appear in the status variable. MyISAM key cache efficiency. So you can have how much is used. You can also have how efficient is it. How many times are you doing a query on a MyISAM table, and how many times did that query actually use the key cache versus having to go to read from disk. So there's a key reads field, and that's how many reads from disk, divided by the number of key read requests times 100. That's going to give you the cache miss percent. So if you want the cache hit percent, you do 1 minus this. So even though they had a very small usage of the query cache, their miss rate was 0.1%, which basically means they're probably only really using it for their MyISAM system tables, and it's completely cached in memory and stays there, so they never miss their cache. It's always in the cache. Key write requests, so that's how many requests you've gotten to write the index since the server started or since you did a flush status, and then the number of actual writes. So if your key write requests is a lot different from your key writes, you probably are, you might be delaying and batching them. It could be that there's a request and they haven't been synced yet, so you get this key blocks not flushed. That could be why too. So usually it's the same though. Transaction basics. So now we're getting transaction stuff. MyISAM is not transactional. If you were sleeping through the MyISAM portion, you should probably wake up. My 10-minute warning hasn't gone off yet, but it's 2:38. We have a break at 3. Okay, so we can start getting into this. I didn't want to start getting a big section if we were 5 minutes away. Auto commit, by default, auto commit is on. What this means is that every statement when you hit return will commit. So if you've ever used Oracle or whatever, you actually have to specify commit after when you want it to commit. MySQL has auto commit. Now, auto commit is turned off when you type begin or start transaction. That will turn the auto commit off just until you hit commit or rollback. But by default, auto commit is on. By default, you could be using the MyISAM table, who knows. This isn't really a problem for most of us who have, kind of been primarily in the MySQL space. This is just how we know it works. But I know I've gone to do some, our internal databases at our company are actually Oracle, and I've gone to do some changes and be like, oh, let's add this new client in and their machines to monitor. And then like the next day I'd be like, I added that client yesterday, what happened? And they're like, oh, you didn't commit. And I was like, oh, I was supposed to commit? Like, I just thought it auto-committed like MySQL. So there you go. The transaction isolation by default is read committed. The completion type, this is a best left alone. The default is 0, and that means commit. If you set it to 1, the default is commit and chain, which means commit and immediately start a new transaction. So I guess if you do want that kind of functionality of always be, you don't want to turn auto commit off, but you want that kind of value maybe for your session only. You can set the completion type to 1. And the same with rollback. If you do a rollback, it will do rollback and then immediately open a new transaction. So if you set this to 2, if you set completion type to 2, and again I've used a dash instead of an underscore here, I see. It just, the underscore and transaction isolation made me think of it. If you do a commit, it actually does a commit release, which will commit and close the session. Same with rollback. If you do rollback, it does rollback and close the session. So most often, you're probably just going to want the completion type to stay like this, and whenever you want to do a transaction, you type begin or start transaction, and that's how you do it. So, foreign key checks. This is a session variable only. You can turn off foreign key checks. This is not recommended. Sometimes, however, when you're loading data, for example, MySQL dump, at the beginning of an export file, MySQL dump will actually write set foreign key checks equals to off, because the way MySQL dump works is it goes in alphabetical order, and it dumps tables with the letter A first, and then the letter B, and then the letter C. So if you have something earlier on that's dependent on something later on, for example, like let's say your orders table has a foreign key to your users table. If you're importing, you're going to get to the orders table first, so you have to turn the foreign key checks off, because you can't check for foreign keys if you create the table orders and you say, okay, now I want to have a foreign key to the users table. When you haven't loaded the users table data in, it's not going to work. It shouldn't be too hard to program MySQL dump to do the right thing, but nobody's done that yet. After about 4.0 they did it? Really? Because in my versions of MySQL dump, it still goes in alphabetical order.
It puts the foreign key check.
Yeah, it puts the foreign key checks in. What I'm saying is it shouldn't be hard to actually figure out the dependencies, especially now with the information schema. It shouldn't be hard to just figure out the dependencies and say, okay, here, let me dump all the table, let me export all the tables first that have no dependencies. Then let me export the tables that have dependencies on those, and then the tables that have dependencies on those. And again, it should not be too difficult to do that. It might take maybe 5 seconds more to actually run, but it just hasn't been done. I guess it's not a big deal, but some people will do that, again, when you're loading data. So especially if you know that the data is accurate, then you don't have to bother to do the checking, so it's faster, right? Because otherwise you'd be like, okay, I'm going to insert this row. Now does this value match this value here? Okay, great. You can eliminate that check by doing this. It's a session variable for a very good reason. You do not want to globally turn these off. That's called MyISAM, actually. All right, we're having sleep comas because one person laughed at that joke. That was a great joke. That was such a great database joke. That was, yes. Anyway, transaction pre-alloc size is the starting or ending size of a shared per transaction memory pool. So if you're having this if you have a transaction and you have a memory pool, this is what will start and end. Just like we had net buffer length was the start and end of a query, and the maximum was max allowed packet. This is it for a transaction, not just one query. transaction allocation block size. If a per transaction memory pool needs more memory, so you start with 4 kilobytes. If you need more, you increase it by 8 kilobytes at a time. InnoDB basics. Who here is using InnoDB? Everyone. Woohoo! All right. The InnoDB data file path is where you have your IB data file. Your IB data file has at least the data dictionary. If you are using InnoDB file per table, the IB data file is just metadata and the data dictionary. If you are not using InnoDB file per table, it has the metadata, the data dictionary, and all of your data and indexes. Why, again, if I ruled the world, by default, InnoDB file per table would be on, but I don't rule the world, so it's not. InnoDB auto extend increment. Basically, when you need to, if you do, so this is the name of the data file. You can also have a path if you want to it. Otherwise, it will put it in the InnoDB data home dir. So this server would have in the InnoDB data home dir, which is blank, would actually be in the data dir. It would be called IBData_primary. Usually this is IBData 1, IBData 2 is what most people do. Colon 128 meg, that means initialize it at 128 meg. Auto extend means and now extend it out. You can also specify, you can also have colon max and have a maximum value for it, so you don't go over a certain amount. The auto extend increment is 8, and that's what it's going to auto extend by when it auto extends. Yes.
Does that apply to file per table?
Does it apply to file per table? Yes. Because file per table by default is auto extend. There's no way to not auto extend a file per table.
So tiny InnoDB files end up taking 8 meg or whatever.
So yes, so tiny files will still end up taking, no, you mean this 128 meg? No. The increment, if it needs to auto extend, yes. If it needs to extend, yes. Yeah, if I ruled the world, everybody would be InnoDB file per table. Well, that would be the default because usually most use cases don't have tons of tiny InnoDB files, right? It's okay to have 1 or 2 wasteful, really tiny InnoDB tables because it's not really going to affect much. You get into a problem when you have a million different ones that are really tiny. Most people don't have that. Most people have a couple of dozen InnoDB tables. I mean, how many people here have, if you know, how many people here have like under 100 tables in your production database, let's say? Okay, well, how many have under 500? Okay, how many don't know? Okay, so yeah, I mean, you pretty much, unless you're like an ISP, like ISPs have this problem a lot where, if you did do that, actually, you'd also fragment on your file system, and if you used disks that spin and seek, it would take a lot to go there. So in those kind of cases, a centralized data and index file is a good idea. But most cases, you really want InnoDB file per table. So so here are some flags, which is usually on or off, although in MySQL sometimes you get on, off, and a third option, because we like to override true, false, and maybe. Ignore built-in InnoDB, it is off by default. This is as opposed to using a plugin, so obviously this is a newer variable. So by default, you use the InnoDB built-in as opposed to ignoring it. These double negatives sometimes get me, I have to think about it for a while. InnoDB flush log at transaction commit. This is one of my favorite variables because it takes a long time to explain it and it's very, very important to understand it. Basically, there's 3 values, 0, 1, and 2. 1 is the default. Now, this is for the InnoDB log buffer, which we haven't talked about yet, but we will. So this is not for the InnoDB data files. This is not for the InnoDB buffer pool. It's not the cache for InnoDB. It's the log buffer, so the cache of the InnoDB log when it is flushed to disk. When does that happen? The default is 1, which means that with each commit, the log is synced to the disk. This is good for durability, but it also can do a lot of file I/O if you're committing 100 times a second or more. If you have it at a setting of 0, that means that it's not going to flush it at transaction commit. It will flush it once per second. So it writes, the log buffer is written once per second and flushed. So it does both. It writes once per second and it's flushed at the same time. Okay? If you have it at 1, remember, it's written at commit and it's flushed at the same time. If you set it to 2, the log buffer is written on every commit, but it's flushed once a second. So your disk I/O goes down a little bit, and it's not completely durable because you have that 1 second of, it might have been written to memory, but not to the disk. But it's usually something that can really help a lot of file I/O situations. InnoDB fast shutdown. So one thing to know about InnoDB is that it can take a while to shut down and or start up, because what it basically has to do is it has to close everything, just like MyISAM does, but it also has to say, okay, I've got these dirty buffers that I've written, this data. So InnoDB works, the way it works is that it has a buffer pool, and that's data and indexes. So it's a data and index cache. And when you write to InnoDB, what it does is it changes the data in RAM, and eventually flushes to disk. So when you shut down, you have to flush all that data to the disk. That can take a long time, because usually, by default, InnoDB doesn't, MySQL, InnoDB doesn't actually flush the data until you get to about 95% of your buffer pool pages written to, dirty. So if you shut down, if you have an InnoDB buffer pool size of 8 gigabytes, and you shut down, you might have been at 90% dirty, so you have to wait for the 90% of, well, let's say 10 gigabytes, because the math is easier, right? You'd have to wait for 9 gigs of data to write to disk. That could take a long time. So, for faster shutdown, so what happens, so basically, if you have fast shutdown set to 0, what it will do is it'll do a full purge of the insert buffer merge, which is basically do all of the writes. It'll do that full thing before shutdown. If you set it to 1, which I believe is the default, it will skip. That's a 10-minute warning. If you set it to 1, it will actually not do this full purge and insert buffer merge before shutdown. It skips it. But it has to do it at startup. So there's no way to avoid this. It's just, do you want to do it on startup or do you want to do it on shutdown? Now, you can also set it to 2, which basically flushes logs and it shuts it down cold as if there was a crash. There's no committed transactions would be lost, but there will be crash recovery done on startup. So if you want to simulate a crash, use InnoDB fast shutdown equals to 2. So let's see, let me see if there's a couple more, actually there's about 4, let's see how much more, there's about 4 more slides on InnoDB flags, we'll see how far we get. InnoDB file per table, I already explained how that worked. The thing about InnoDB file per table is that it's a flag used when you're doing a create table. So if you create a table and the InnoDB file per table is on, it will be created with a data file that is external to the data dictionary. Now, this means that if you want to convert your database from centralized data to InnoDB, you could, in InnoDB file per table, what you could do is you could set InnoDB file per table, restart the server, and then do alter table, whatever, engine equals InnoDB, or something that will rebuild the table. It will rebuild the data and index file outside there. However, what that won't do is it won't change the fact that your IB data file is still huge. So most people realize, oh, I need to go InnoDB file per table because my IB data file is 400 gigabytes. And I don't know what I need to defragment. I don't know, like, what's the biggest table? What's taking up the most room? I don't really know. Like, I could look at the information schema, I guess, to find the biggest table. But if you have a .ibd file, what you can do is you can compare the approximate size in the IB data file, the approximate size in the information schema to the actual size on disk of the IB data file. Now, in the information schema for InnoDB, the size is approximate. So if you look at it and you can see that, let's say the size on disk is 20% more than the estimate, that's probably fragmented. If it's 50% more. If it's 5–10% more, probably not. That's probably the estimation error. It's probably that. But if it's really a lot, but you can't do that when you're not InnoDB file per table. So if you really, the best way to convert it so that you can have a smaller data dictionary, smaller IB data file, is to lock all your tables or make sure that nobody's writing to it. Do an export, a MySQL dump of all your tables, of all your InnoDB tables. You don't need to do MyISAM tables. Shut down MySQL. change the InnoDB file per table in the configuration file. You can delete your files. I like to move them just in case I need to move them back. Move your IB data file somewhere else. Start up MySQL again, and InnoDB will be like, oh, I need to initialize my IB data file. You probably also want to change the IB data file to be smaller. A lot of times, if you've already set it to like 10 gigs or something, you don't want it to initialize that large. And then import your tables again. And if any of those steps goes awry, you can usually shut down and move back. You also probably want to move your log file, your InnoDB log files, because MySQL will look at those upon startup. Question?
Do you need to remove the FRMs?
Do you need to remove the FRMs? Yes, you do, because as we said before, if you have a table, if you have a .frm, MySQL will believe there's a table there. So yes, you do need to remove the .frms too, which is actually a step I often forget. But it's easy enough to fix, because what happens is I try to import the tables, and it's like, oh, table already exists. And, what do you mean table already exists? I just moved the IB data file out of the way. So it is something I always forget, and I even forgot to say it. But it's not a problem if you forget it, because when you import it, you'll be like, I can't import, the table already exists. And you're like, what do you mean the table already exists? There's no InnoDB tables at all. And then you'll look and you're like, oh, I forgot to move the FRMs. So one of the things that I like to do when I do this is I look at the information schema and I select the tables that have that are InnoDB. So select table name from information schema .tables where engine equal InnoDB, and I get all those names, and then I make a couple of, I copy and paste them, and then I make a couple of scripts. So one to export that table, the database and table name, into a file. One to import it into the database when you need to import, and one to move all the .frm files. Again, you can delete them if you want, but I prefer to move them. Just because if you need to go back, you can. So InnoDB stats on, InnoDB locks unsafe for a bin log. What that means is that you can, I don't know what that means. I don't have notes here on that. That's bizarre. I don't just want to say, oh, the locks are unsafe for binary logs. I think what happened was when I was writing these slides, I was probably had it memorized, and now it's out of my brain. But let's talk about InnoDB stats on metadata. What I'll do is during the break, I'll get what locks unsafe for bin log is. Other than it uses locks that might be unsafe for binary logging, which the name is pretty accurate there. InnoDB stats on metadata. What that means is when it's on, which is the default. It's on as default, and also before 5.1.35, because this parameter, this option came in 5.1.35. So the behavior in 5.0 and whatever was that it's on, and by default it's on. So when that's on, InnoDB will update statistics during metadata statements when you do like a show table status or show index, or when you're getting information schema tables or statistics. So you can also set it off, and when it's off, InnoDB does not update statistics during those operations. So if you disable that, it can improve speed when you're doing, selecting from information schema, or doing a show table status, or doing show index. So if you have databases that have a large number of tables or indexes, turning that off might help. Again, though, this is global, not per table, so you don't really get a choice. It can be on or off. This is one of those things that you might tweak to just like, let's get a little better, a little better, a little better. But again, then your statistics aren't updated when you run those statements, and usually it's best to have the most updated statistics that you can have. Not that InnoDB does very good statistics collection anyway. So let's just do this final InnoDB use legacy cardinality algorithm. This was also put in 5.1.35. By the way, the first GA release of 5.1 was, I don't know, October of 2008 or something like that. And it was 5.1, I think 30 or 31 or 32, something like that. So basically, very shortly after the first generally available releases, this parameter came in, and it's basically if you turn this off, there's a better randomization of index cardinality. If it's on, there's better sequential access to the index cardinality, and because it's a V tree, you pretty much want a better sequential access of it. Again, if you really need that, I would probably just use a hash index instead of a V tree index, as opposed to turning this on, this off. So using the legacy is on by default. With off you get, the better randomization, but again, I don't know why one would use it and why one wouldn't. It's kind of a newer variable, and I've never run into a situation where, you know, you call MySQL support and they're like, no, you need to turn that variable off. So, again, it's probably better to change your index itself, because it's one of those things where you probably don't want it on a global basis. You want it on a particular query or something. So, that having been said, let's take a half-hour break.